Students, good morning students. So yesterday we did two examples of exercise 5.8. Let us continue with those examples. I had asked you to try the example third one. Did you all try, students? Yes? Did you all try? Did you all try those examples? Anyone? Okay, so let us go for the third question. What is the third question? If a function f from closed interval minus 5 to 5 to r is a differentiable function, and if f dash of x does not vanish anywhere, then prove that f of minus 5 is not equal to f of 5. See what all things are given, students. First of all, they have given us the function f whose domain is in closed interval minus 5, 5 and whose range is set of all real numbers. Secondly, what they have given us that it is differentiable function. They have already given that it is differentiable function. Last third thing what they have given is important. They have told that f dash of x does not vanish anywhere. What does that mean? It means that f dash of x is never equal to 0 for any x belonging to R. This is the third given to students. F dash of x doesn't vanish anywhere means f dash of x is not equal to 0 for any value of x. To take any value of x, this is true. That is, f dash of x will never be equal to 0 for any x belonging to R. So this is the third given thing. Okay, now let us see. We have to prove that f of minus 5 is not equal to f of 5. This is to show that the function value at these two points are not equal. So which theorem comes to your mind when we say that function values are not equal at n points? Yes? Is it Rolle's theorem or mean value theorem? I hope you remember what is Rolle's theorem and what is mean value theorem, right? So which theorem comes to your mind when I say that function values are not equal at n points? Yes? Anyone who can answer? Very good. Very good, January. Mean value theorem comes to our mind, right? Because in mean value theorem, we have a function which is continuous on closed interval AB. It is differentiable in open interval AB, but function values at n points are not equal. Then only there exists some point in open interval AB such that f dash of c will be equal to f of b minus f of a divided by b minus a. So this is nothing but mean value theorem, right? So let us apply mean value theorem here also. First of all, they have given that function is differentiable. They have given that the function is differentiable on open interval AB, that is open interval minus 5, 5. They are told that this function is differentiable function. Now, in continuity, we had studied one continuity and differentiability. We had studied one concept, right? Like one theorem, in the form of theorem, we had studied a differentiable function is always continuous. Right? This theorem we had already studied that a differentiable function is always continuous. Since this function f is differentiable, can I say that it is continuous? Yes, of course we can say, because we have learned the theorem. What is the theorem? Every differentiable function is continuous. So from that theorem, we can conclude this statement that the function is continuous on closed interval minus 5, 5. Now observe here, students, we have two things. The function is continuous on closed interval minus 5, 5. It is differentiable on open interval minus 5, 5. So can we apply mean value theorem, students? Because we have not So now, what in the given thing, what we already knew students, we third thing, what was given? They told us that f dash of x doesn't vanish anywhere. Means what? F dash of x is not equal to 0 for any x. Right? It is not equal to 0 for any x. So here you can see we have f dash of c. So from that given thing, can I say that f dash of c is not equal to 0? Because as I have told that f dash of x is not equal to 0 for any x. So we can say that f dash of c is not equal to 0. Means this part is not equal to 0. Right students? Since f dash of x is not equal to 0 at any point x, f dash of c will be not equal to 0. So this part will be not equal to 0. So if you simplify these things, if this part is not equal to 0, then this thing goes to the other side. So you get f of 5 minus f of minus 5 is not equal to 0. Because this denominator thing is multiplied here to 0. So that will be f of 5 minus f of minus 5 not equal to 0. If you take this part to the other side, what do you get? F of 5 is not equal to f of minus 5. F of 5 is not equal to f of minus 5. Thus, we have proved that the function values at the end points are not equal. They are not equal. I hope everyone understood the sum students. It's very easy. Do you understand? Any doubts in this example? Okay. Now let us go for the fourth question. So the fourth question here is, you verify mean value theorem. Verify mean value theorem if f of x is equal to x square minus 4x minus 3. In the interval a comma b, where a is equals to 1 and b is equals to 4. So we have to verify mean value theorem for this function, where a is equals to 1 and b is equals to 4. Means the interval given to us is, this interval is nothing but 1 comma 4 seconds. Okay. In the interval a comma b, where a is equals to 1 and b is equals to 4 means what? That interval is nothing but 1 comma 4. It is 1 comma 4. So we have to verify mean value theorem of this function on this interval 1 comma 4. So let us do it step by step. Observe here. This function is a polynomial function, right? This is a polynomial function, students. So as I told you, polynomial function is continuous everywhere. This function will be continuous in this interval also. Right? Since it is a polynomial function, f is continuous on closed interval 1 comma 4. It will be continuous on closed interval 1 comma 4. Now to check the differentiability, what we will do, we will differentiate this function. So what will be f dash of x? If you differentiate this function with respect to x, what is f dash of x? Yes, what is f dash of x, students? Please tell me. Only 2x. Zainabi? Only 2x will get 2x minus 4. Observe here. X square differentiation is 2x. Minus, what is differentiation of x? It is 1. So minus 4x differentiation is minus 4. Next, minus 3 differentiation is 0. The differentiation of this function f is f dash of x is equal to 2x minus 4. So you can observe this is again a polynomial function. It is differentiable. So f is differentiable in open interval 1 comma 4. Right? It is differentiable in open interval 1 comma 4. So both the conditions of mean value theorem are satisfied. See, third condition which I told you in mean value theorem, function value at endpoints you have to check, and you have to see if they are equal or not equal. See, if they are equal, then you are going to use Rowe's theorem. If they are not equal, then you are going to use mean value theorem. Right? Here already they have given us that you are to use mean value theorem. Right? So no need of checking that third condition here. Obviously, they have told that if you have to use mean value theorem, so there is no need to check that third condition. Okay? Now, both the conditions of mean value theorem are satisfied. So by mean value theorem, by MVT mean value theorem, there is some point C in open interval 1, 2 such that f dash of C will be equal to f of 4 minus f of 1 divided by 4 minus 1. So there is some C open interval 1, 4 such that f dash of C is equals to f of 4 minus f of 1 divided by 4 minus 1. Now what you have to do is, students, here we have f dash of x. What is f dash of x? It is 2x minus 4. So in place of x, you substitute for c. What you get? You get 2c minus 4, right? In place of x, you have to just substitute c. So you get it as 2c minus 4. And that is done. We have f dash of x here as 2x minus 4. What is f dash of c? Now, what is f of 4? Function. Function was x square minus 4x minus 3. So f of 4 would be 4 square minus 4 into 4 minus 3. Minus. What is f of 1? 1 square minus 4 into 1 minus 3. Divided by 4 minus 1 is 3. I hope you understood it. I just substituted. Okay. So if you solve this whole thing, you will get the value of c as 5 by 2. If you solve this whole thing, you will get c value as 5 by 2. And you can observe, students, this 5 by 2 will lie in my interval 1, 2. You can observe. See, 2 ones are 2s are 2 point something you get. And that is nothing in this interval only, right? This 5 by 2 value will lie in this interval. So, for this value of c will satisfy this equation. So, for this value of c, this is satisfied. Thus, for the function x square minus 4x minus 3, mean value theorem is satisfied. Mean value theorem is satisfied. Did everyone understand, students? Yes, did you all understand? Okay. Similarly, you have to do the fifth question. Fifth question, it is cubic polynomial. In the same manner, you have to do the fifth question and check what will be c. Okay? In a similar manner, do all the steps for fifth question and you have to get the answer. We are right now. Can you tell me the answer right now? I'll give you 10 minutes. Start doing the fifth one. So fifth cubic polynomial is given as similar steps you have to follow. It is x cube minus 5 square minus 3x in the interval 1, 3. So this is the function and this is the interval 1, 3. Will you do it as homework? You have to repeat the same steps which we have done in example 4. And you have to come with a point C in open interval 1, 3 using mean value theorem itself. Will you do it as a homework, students? Yes? Or I'll give you 10 minutes. You can check it, students. It will satisfy mean value theorem, and the value of C you will get here is 7 by 3. You will get it as 7 by 3. This will be the right answer. Actually, you will get two values. You will get C is equals to 1 as well as C is equals to 7 by 3. But this you will not consider. Why? Because this C is equals to 1 will not belong to 1 does not belong to this interval 1, 3. Okay, you get two answers. You get 1 as well as 7 by 3. But as this 1 does not belong to my interval 1, 3, you will not include this as an answer. So this will be the answer, 7 by 3. Okay, please check it. So let us go to the last question. Sixth question. Examine the applicability of mean value theorem for all the three functions given in above exercise 2. See, in second problem where we had checked Rolle's theorem, right, for three functions. We have given three functions. Let me write those functions. This one, first function was f of x is equals to the greatest integral function of the interval 5 to 9. Second function was again the greatest integral function, but the interval was changed, it was minus 1, right? Yes. And what was the third function? It was f of x is equals to x square minus 1 on the interval 1, comma. So these three functions we checked in example 2 whether it is Rolle's theorem is applicable or not, right? So let us just revise that once. So for the greatest integer function, Rolle's theorem was not applicable since greatest integer function is not continuous as well as it is not differentiable. Both these functions. These both are greatest integer functions, right? Since greatest integer function is not differentiable as well as it is not continuous, these two are not applicable for Rolle's theorem. Third one, it was continuous, it was differentiable, but the third condition of Rolle's theorem failed here. What was the third condition? F of 1 equal to f of 4. Here you can observe f of 1 is not equal to f of 2. So the third condition of Rolle's theorem failed here. So this third one function is also not applicable for Rolle's theorem. So Rolle's theorem is not applicable for all these three functions. Now in sixth question, they have asked us to check whether mean value theorem is applicable for these three functions or not. So let us do one by one. Let us consider the first function. So tell me, students, whether the first function is applicable for mean value theorem or not. Is mean value theorem applicable to that function? First function. Mean value theorem conditions are what, students? First condition is it should be continuous on closed interval AB. Second condition is it should be differentiable in open interval AB. And third condition also we have, that is function values at the endpoints. F of A should not be equal to f of B. So is the mean value theorem applicable for this first function? Please answer, students. Is the mean value theorem applicable for this first function? Yes? Is it applicable? See, it is greatest integer function. Greatest integer function is not continuous as well as it is not differentiable. So both the clear? Is it clear to everyone? So with this, we have completed with the chapter continuing differentiability. It is the biggest chapter in PU2, one of the biggest chapter in fact, carrying 44 marks. So we have done with all the examples as well as all the concepts. I hope the topic is clear to you all. If you have any doubts, then just let me know. We'll clear those doubts. Were the concepts clear, students? Is the topic clear to everyone?